Hello guys, in this video we are going to revise the extraction of copper. Okay, so this question is adapted from Science Paper 2 2016. Okay, so the statement above reads, one major ore of copper is copper pyrite. To extract copper from the ore is crushed, then undergoes froth flotation, and finally roasted in the air. Then the metal is then purified by electrolysis. Okay, so I'll begin by mentioning some of the ores from which copper is extracted. Okay, so we have the copper pyrite, the cuprite, and the malachite. Okay, so the copper pyrite is the ore they call the chief ore. Okay, so it is also known as the chief ore for copper. Okay, and we have three stages in the extraction of copper. Okay, so the first stage is where the copper has to undergo froth flotation. The second stage is where the copper ore is roasted in air, and lastly, refining of impure copper. Okay, so we are going to begin answering from question A. Okay, so the first question, question A, is asking to say, explain why the copper ore has to undergo froth flotation. Explain why the copper ore has to undergo froth flotation. Okay, the copper ore has to undergo froth flotation in order to increase the concentration of the ore. Okay, so by increasing the concentration of the ore, it means you are also removing the impurities. Okay, question A2. Explain why the copper ore is roasted in air. Explain why the copper ore is roasted in air. Okay, so the copper ore is roasted in air to simply convert the ore to copper sulfide. Okay, the copper ore is roasted in air to simply convert the ore to copper sulfide. Okay, question B. Write a balanced chemical equation for the reaction that occurs when the copper ore is roasted. Write a balanced chemical equation for the reaction that occurs when the copper ore is roasted. Okay, so writing a correct balanced equation, you firstly identify the ore they have given you. Okay, so since they have given us the copper pyrite, and in the statement we've been given the chemical formula for copper pyrite. Okay, so that's the chemical formula. So since it was being the ore was being roasted in air, it means this ore was reacted with oxygen. Okay, so this is a balanced chemical equation. Okay, so the copper sulfide we are seeing, the copper sulfide is also known as blister copper. Okay, so the blister copper isn't the copper we are looking for. We just want the pure copper. Okay, so the blister copper obtained is further oxidized at the anode furnaces to remove the dissolved sulfur. Okay, so for us to get the pure copper, we should react this blister copper, which is copper sulfide, with oxygen. Then we're going to have the pure copper and sulfur dioxide. Okay, so the sulfur dioxide is a waste gas. Okay, so the sulfur dioxide is a waste gas, and this waste gas can be converted into a harmless substance. Okay, so the sulfur dioxide is taken to the acid plant where it is reacted with the water to produce sulfuric acid. Okay, so sulfuric acid is also used in batteries. Okay, so question C. The physical properties of copper can be explained in terms of metallic bonding. The physical properties of copper can be explained in terms of metallic bonding. C1. Describe with the aid of a labeled diagram the metallic bonding in copper. Okay. So the atoms in copper are held together by strong electrostatic forces of attraction between the proton in the nuclei of the element and the delocalized electrons around them. Okay, so by delocalized, I'm trying to say electrons are free to move. Okay, electrons are free to move anywhere in the lattice. Okay, so the atoms are held together by strong electrostatic forces of attraction. Okay, so this is a diagram we can display. Okay, so this is a diagram we can display. C2. Question C2. Explain how metallic bonding makes copper to be malleable. Explain how metallic bonding makes copper to be malleable. Okay, so when something is malleable, it means it can be drawn into sheets. Okay, it can be drawn into sheets. So this is one characteristic of metals. Metals are malleable. Okay, so now the question is, explain how metallic bonding makes copper to be malleable. Okay, so when the metal is hammered or beaten, the metal we are talking about is copper. So when it is hammered, the metal is hammered, its atoms slide each other but break because of the attraction between the atomic nuclei and freely moving delocalized electrons. Okay. Question D, the last question. State one use of copper. State one use of copper. Okay, so copper is used to make electrical cables. Okay, copper is used to make electrical cables. So there are many uses of copper. Okay, you can add yours in my comment section below. This question is adapted from Science Paper 2 2016. Okay, so this question is under the preparation of nitric acid. I warmly welcome you to my YouTube channel. Remember to subscribe and give a like to this video you are watching. Okay, so I'll read the statement above and we're going to answer these given questions. Okay, so the statement reads, nitric acid is an important acid in everyday life. Okay, nitric acid is an important acid in everyday life. Okay, so the first question is asking to say, name the commercial process used to prepare nitric acid. Name the commercial process used to prepare nitric acid. Okay, so the commercial process used to prepare nitric acid is referred to as the Ostwald process. The Ostwald process, not Oswald process, but Ostwald process. Okay, so this was the name of a German chemist. Okay, question B. State the catalyst used during the commercial preparation of nitric acid. State the catalyst used during the commercial preparation of nitric acid. Okay, so the catalyst used is platinum rhodium. Okay, platinum rhodium. In some books, they have separated these two words. So if you want, you can put platinum or rhodium gas. Okay. Question C. The equation below shows the initial stage in the industrial preparation of nitric acid. The equation below shows the initial stage in the industrial preparation of nitric acid. Okay, so this is the first stage in the preparation of nitric acid. Okay, and it is from this stage where the catalyst is now these two catalysts are put. Okay, so the two gases, which are the ammonia gas and oxygen gas, are passed over a platinum rhodium catalyst, okay, at the temperature of 900 degrees Celsius, okay, and at a pressure of 8 atmospheric pressure. Okay, so it is also important to note that this process is an exothermic process. Okay, so copy and balance the equation. Copy and balance the equation. Okay, so this is a balanced chemical equation. Okay, so some equations just need to put, for example, A2, then it is balanced. So when balancing up equations, use a pencil to avoid erasing. Okay, question D. The nitrogen monoxide produced as shown by the equation in C above reacts with oxygen to give nitrogen dioxide. The nitrogen monoxide produced as shown by the equation in C above reacts with oxygen to give nitrogen dioxide. Okay, so this gas we are seeing above here, which is nitrogen monoxide, is going to react with oxygen. Okay, so let us construct a balanced chemical equation for the reaction. Okay, so it's nitrogen oxide reacted with oxygen, and the product is going to be nitrogen dioxide. Okay, so this is a balanced chemical equation. Okay, question E. Question E. How is nitrogen dioxide converted to nitric acid in this process? How is nitrogen dioxide converted to nitric acid in this process? Okay, so nitrogen dioxide is dissolved in water to produce dilute nitric acid, and nitrogen monoxide is also produced. Okay, so when nitrogen dioxide is dissolved in water, yes, air is also present, so the nitrogen dioxide is absorbed in hot water to produce dilute nitric acid. Okay, that's how the dilute nitric acid is formed. Okay, question F. Question F. Explain why the concentration of nitric acid cannot be made more than 68% even if it is distilled. Explain why the concentration of nitric acid cannot be made more than 68% even if it is distilled. Okay, so this dilute nitric acid or nitric acid is about 50% by mass. It is distilled but cannot be made more concentrated than 68%. Okay, so now why? So this is because it forms a constant boiling mixture with water. Okay, just that simple reason. It forms a constant boiling mixture with water. This is why it cannot be made more concentrated than 68%. Question G. Explain why higher concentrations of nitric acid can only be obtained if it is mixed with concentrated sulfuric acid and redistilled. Explain why higher concentrations of nitric acid can only be obtained if it is mixed with concentrated sulfuric acid and redistilled. Okay, so as sulfuric acid has strong affinity for water, and so only the volatile nitric acid is distilled. Okay, question H. Give any two uses of nitric acid. Give any two uses of nitric acid. Okay, so this one, put your answers in my comment section below. Thank you for watching.